Very good morning, all. Yes, please respond. Did everyone join it? Shall we start the class? Yeah, very good morning. Okay, let's start this session. See, we are in the edge of numerical methods. Almost our numerical method is over, and apart from this, there is one more model, right? Anyway, before that, yesterday we saw the equations, some formulas only I had just directly given in order to solve the differential equations, right? Now, when we have differential, but the thing is, if your equations are critical, you are unable to solve those equations directly. If you are unable to solve the bring out the solutions directly, those type of equations can be solved with the help of numerical methods, right? So what we saw here, we are using three standard methods in order to find the solution for differential equations, and they are called what? Euler forward method. It is also called explicit method, and then Euler backward method is also called implicit method or modified Euler method, right? And then we had discussed about Ranjikuta method, right? So that is simply there are three methods in order to, there is three different equations we saw in order to find the solution for second order equations, third order equations, and fourth order equations, right? Okay, and before starting solving problems, I would like to conclude a few more things. See, already we had been discussed the methods in order to find the solution for integrations, right? Now, அதில் நம்ம என்னென்ன மெத்தட்ஸ் பார்த்துருக்கோம் in integration. If you want to find the solution for the integration, we have to go up with three methods, right? So first we had been discussed about trapezoidal rule, and then we had been discussed about Simpson rule. In Simpson rule, in the sense it's Simpson 1/3 rule, and then we saw there is one more method, that is Simpson 3/8 rule, right? Now there yesterday we had a great discussion, right? The discussion is when we are going up with the higher order differential equation, right? From myself, I would like to confirm few things. That is, ஒரு சிம்சன் 3/8 ரூல் நம்ம எடுத்துக்கிட்டோம் அப்படின்னா மேக்ஸிமம் எவ்வளோ ஆர்டர் வரைக்கும் அதனால் வந்து அக்யூரேட் ரிசல்ட் வந்து கொடுக்க முடியும். அட் தி சேம் டைம் சிம்சன் 1/3 ரூல் அண்ட் ட்ராபிசாய்டல் ரூல், அட் தி சேம் டைம் டிகிரி எவ்வளோ டிகிரி வரைக்கும் அதில், பிகாஸ் already I had given some conclusions regarding that, but based on these conclusions that I brought yesterday, right, with some of my faculties, right, in that research I realized one thing, right? Actually, if you are going up with the trapezoidal rule, Simpson rule, and Simpson 1/3, that is Simpson 3/8 rule, while raising the order, actually trapezoidal rule will give us the exact result only up to second order only. Similarly, when we are going up with a Simpson 1/3 rule, it will give us the exact result up to third order only, not fourth order. Please correct it, right? So let me write those things clearly on the board. See, I'm talking about indefinite integral methods that we saw yesterday, right? So in these integral methods, first one is trapezoidal rule, right? So let me clearly write down all those things, right? Trapezoidal will give exact result, right? Only for exact result, in the sense we can raise the degree up to 1, and you can go order up to 2. That's all. Order is only 2, right? Similarly, when we are looking for Simpson 1/3 rule, Simpson 1/3 rule or Simpson rule, simply we are calling Simpson rule, right? And it raised the, right? So we can here we can go up to degree 2, and order of the system should be raised to 3. Next, when we are looking for Simpson 3/8 rule, Simpson 3/8 rule, here we can raise the degree up to 3. We can raise the degree up to 3, and we can raise the order of the system up to 4. Order of the system up to 4. This is the correct things, right? So if you go beyond 3 in Simpson 1/3 rule, then you might face error. If you go beyond 4 in Simpson 3/8 rule, then you may face error. So according to that conclusion, when your order of the system, right, will become greater than 3, then there is a chances of getting error. Again, when the order of the system will become greater than 5, then there might be a chance of getting error. Here also in trapezoidal rule, if you raise the order greater than 2, if you go greater than 2, again you will face the error, right? So it will be represented by, that is order with a step size up to 2, and this is order with a step size up to 3, and it will be simply represented order with a step size 4. Clear? So that is the standard things that we are observing in our integral rules. Now here, I hope you all remember, I had defined a certain formulas in order to find out the truncation error in our last class. Right there, actually I made a great mistake. That mistake is, see, according to this conclusions that we brought yesterday, right? When we are going above 3, then only the problem of error is started arising into the system. It means, right, now I wrote two equations, like while for trapezoidal rule, in order to find out the truncation error, let me write the truncation error formula for trapezoidal rule. See, trapezoidal rule will give us exact result up to order 2, right? That great conclusion we brought yesterday. So from this we understood, if it is that is up to 3, up to 2 we don't have any problem. When the step size will be raised to 3, right, order, when the order will be raised to 3, that is the point where we are facing the error, such that your derivation will become second derivative, right? And the rest of things are same, and in the denominator we are going to get 12. Of course we have minus also. This is the error formula for a trapezoidal. Now for Simpson, this is called 2 points, right? In trapezoidal we are considering only 2 points now, we all know. And in order to, in Simpson rule, we are not deriving any equations for Simpson 3/8, but standardly for Simpson or 3 point, for 3 point we have the truncation error formula. That things I had defined already, right? See, this is for one iteration. For n iteration you can multiply it by number of subintervals. Similarly, truncation error, right, for 3 points, right? So this is 3 points, we all know. In Simpson 1/3 we are considering only 3 points. For this one, its correspondent truncation error formula is going to be minus, see there, up to order 3 we don't have any issues here. If you don't have any issues, then we could not consider this one, right? We should raise this step size with the order 4, and then you have to consider, right? So the thing is, here I cannot go, wait a minute, let me combine these two things here itself. We have to raise the step size up to, that is greater than 4. Generally I am defining, see, this is, I am taking 3 point rule only, that is for 3 point I am defining, but I am raising the order up to above 3 in the sense minimum we are considering, right? So I am just considering 5, and I am considering these two cases here, right? With the, we are just going up with the 4th order derivative, right? In the denominator, for n interval, right, already I had been told you, without n we are having 90, with the n it will become n/2, such that your formula is going to be 180. See there, listen, actually here we are trying to consider the error for 3 points only, but we are considering common order, right? So generally for Simpson, generally a question like கேக்குறாங்க, right? So in Simpson, right, in order to get the accurate result Simpson அப்படிን general கேட்டாங்கன்னா, we should go, commonly we can define up to 4th order there is no error in Simpson rule, that is common. But if you are specified, if you are being specified in your exam, find the accurate result in Simpson 1/3, then degree 2 order 3, Simpson 3/8 degree 3 order 4. But generally for Simpson, right, I am taking 3 point and I am defining these things for common order, right? So I am just raising the order, that is a step size with up to 5, above 4 in the sense we are taking minimum 5, right? And with this, because in order to get the accurate error, that's why, right, I am raising the value up to 5, right? That's fine. So this is going to be the general formula in order to obtain the truncation error for Simpson rule and trapezoidal rule. Clear? So just to correct these two things by yourself, right? already we had a doubt regarding this numerical methods, right? That's why I took the iterations once again and I had evaluated all those things, right? So finally I came to know regarding these things, right? Actually we are following, see, Simpson rule வந்து காமனா கேக்குறாங்க. Even in your examination also காமனா வந்து Simpson rule வந்து எவ்வளவு டிகிரி வரைக்கும் better result கொடுக்கும் அப்படின்னு கேட்டா 3. Because in Simpson we have two category. அவங்க ஸ்பெசிஃபிக்கா Simpson 1/3 or Simpson 3/8 அப்படின்னு மென்ஷன் பண்ணலனா you should common answer is in Simpson we can go up to order 4 and degree 3. In Simpson 1/3 we can go with the Simpson 3/8 we can go with this one. That's all clear. I hope now things are very clear to you all. Just make very clear notes. Okay, let's continue our discussion with the actually we are in differential equation, right? So let's continue our session. Let me rub this one. Just to keep those equations with you, right? Till now there was no questions, right? If you find any questions, if I will find, then definitely I will solve, right? Just you have to learn, because you can expect the theoretical questions, right? Degree and the order la most of the times you will be tested with the theoretical questions, right? Fine, let's continue our discussion with the differential equations, because we are in differential equation only. So let us take some examples, right, in order to find out the in order to understand how to do the iterations with the differential equations, right? Fine. So first what we saw yesterday, we had been discussed about 3 methods, right? Now let us take a common equation. Let's try to I'm just teaching you how to obtain that is how to proceed with the help of Newton methods and Ranjikuta method, right? Just understand the procedure, that is enough, right? You are not supposed to learn blah 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 things, stories, right? Fine. Now for an example, I'm just considering a function f of x comma y, and that function is simply defined as x plus y. That is enough. We will take very simple value, right? And given it is y of, that is y naught of x naught, right? Y of x naught is equal to what shall we do now, or otherwise let me consider y of 0 is equal to 1. Let's consider like this, right? It means given it is, that is the initial condition. Let's take that is the initial condition. I told you now, while solving the problem we have to keep two datas. One is dy by dt, right? Sorry, dy by dx, right? So this function can be treated as dy upon dx. Clear? Fine. That is the slope equation or differential equation. Fine. Anyway, function is defined now. Yes, f of xy is given to us. Now our target is we should solve this equation first method by using Euler method. Let us discuss about Euler method. What we saw, this is called Euler forward method or explicit method, right? Not implicit, explicit method. Let's proceed. What we saw, the general formula is yn plus 1 equal to yn plus step size h into f of xn comma yn, right? Anyway, step size will be given in your exam, you don't need to be panic. Let us consider step size is 0.25. Step size is 0.25. Guys, if step size is 0.5 and you are requested to continue your iteration, you are requested to find the value of y3, right? Just we shall proceed up to y3 varaikku nama polam. That's enough, right? The question is find the value of y3. Just we should estimate the value of y3. Let's see what will be our answer. First of all, step size is clearly given and the initial value, see there, x equal to 0 where y is equal to 1. Clearly data is given, so we can say x naught equal to 0 and y naught equal to 1. Initial data were given, and we can also continue x oda value நீங்க ஈஸியா ஃபைண்ட் பண்ணிடலாம் just with the help of step size, right? Now let us substitute according to the step size. The next value of x can be, if it is 0, the next value automatically will become 0.25 because step size is 0.25 now. So 0 plus 0.25 will give you 0.25. What about the next value? Again step size is 0.25. So from 0.25 again if you add one more 0.25, then you are going to get 0.5. Next step, you can continue like this, right? So always while going up with these equations, x values are known because initial value will be given for x as well as step size also will be given. So you can tabulate for the value, that is x value we can directly tabulate, but y values are not known. We should proceed. அதுக்கு தான் நம்ம iterationல போக போறோம். Our target is we have to achieve the value of y in terms of what? Numerical methods, because some critical equations cannot be directly solved in normal differential equation. So I am directly trying to find out those roots with the help of what? Euler methods, in order to find out the correct equation, right? Fine. Let's see what happened. Now let me raise. Already we know the value of x naught and y naught, right? Yes. Initial two values are known. Anyway, the question is we have to achieve the value of y3. Now let me raise n equal to, let us put n equal to 0. Because y naught is known, our next value is y1. If you want to know the value of y1, then let n equal to 0 such that y1 will become y naught, because n equal to 0, plus step size h into f of x naught comma y naught. Clear? Now let us continue. Do you know the value of y naught? Yes, y naught is 1, plus do you know the value of step size? Yes, that is 0.25. Do you know the value of f of x naught comma y naught? X naught is 0 comma y naught is 1. We know these two values. Now already I know the value of f of x comma y is equal to x plus y. Now let us estimate the value of f of 0 comma 1. That is very simple. Guys listen, x க்கு பதிலா we have to substitute 0, for y we have to substitute 1. So we know f of x comma y is equal to x plus y. In this function I will have to replace x by 0 and I have to replace y by 1 such that f of 0 comma 1 is going to be 1. Because f of x comma y is known for us, just to replace x and y by its correspondent value that we are getting from the question, right? If I will substitute, then what I will get 1 plus 0.25 into f of 0 comma 1 is equal to 1, such that I am getting 1 plus 0.25 will become 1.25. Yes, happily we got the value for y1. So the value of y1 is equal to 1.25. It's very simple, right? Yes. Let's raise. Let us continue our derivation. Next, we have to find the value of y2, right? In order to find out the value of y2, we should do what? What we have to do? Keep n equal to 1, right? So let us do the same thing, right? But this time I'm going to keep n equal to 1, right? So let us do that one. If we keep n equal to 1, then we are getting y2. Correct? Because 1 plus 1 become 2. Automatically n will be replaced by 1 now, because n equal to 1, and step size h f of x1 comma y1, right? Let's continue. Do you know the value of y1? Yes, y1 is 1.25. Plus, do we know the value of step size? Of course, that is 0.25. Under f of x1 0.25, x1 is 0.25, it is here, comma y1 is 1.25, y1 is 1.25. Now we have to estimate the value of f of 0 comma, that is 0.25 comma 1.25. Again, for x we have to consider 0.25, for y we have to consider 1.25, such that if I will substitute x க்கு 0.25, y க்கு 1.25, 1.25 plus 0.25 will become 1.5. Now let us substitute. So that is going to be 1.25 plus, it is going to be 0.25, right, into this is 1.5. Now what will be the answer? Let us reduce this one, that is 1.25 plus, right? So this is going to be, if I will multiply with these two functions, what we are getting, it is actually 1 by 4, right? So it will be 0.375, right? Yes. So if we are adding these two values, then what I will get, if we had 1 second, that is going to be 5 only, that is 12, remainder is 1, 4, 6, 1.625, right? So that is the value of y2. Yes, we got the value of y2 also. We got y2 also, right? So let's continue our discussion. So the value of y2 is going to be what? 1.625. Anyway, this is not the question. You are supposed to obtain the value of y3, right? So let's continue our discussion. Next, we have to achieve the value of y3, right? So for that, I am continuing. I am doing one more iteration here. Yeah. See, இது வந்து நம்ம எவ்வளோ டைம் ரிப்பீட் பண்ணணும்? Actually we have to repeat this iteration till to get the same value. அப்படின்னா மீனிங் என்ன? Listen, For an example, y3 and y4 ஒரே வேல்யூ வருதுன்னா you have to stop your iteration. That is the correct route. You are almost getting the solution, right? So similar routes. Anyway, here you are not supposed to do that one. That's why this year GATE also they had removed that chapter because of the iteration process, right? So there are no more big things. இதுல வந்து iteration அப்படின்னா in your examination you will be tested for one iteration, two iteration like that only. You are not supposed to repeat the iteration till to get the repeated values. That's not possible actually. You cannot do, right? It's not your semester exam, right? So you no need to be panic, just continue, you will come to know automatically. And the questions are very rare from this area. Let's raise, actually the question is y3, right? Let's say n equal to 2. Rare means don't think that there is no questions will be there and you can find what only very few questions. I'm telling like that. Fine. N equal to 2 na value enanga, that is y2 plus step size h f of, again we have to consider x2 comma y2. Let us substitute. What is value of y2? Y2 is 1.625. You please do it by yourself. Step size become 0.25. Yes, of course. F of x2 comma y2. F of x2 is how much? X2 is 0.5. We know that one. And y2 is 1.625. That is direct forward method, right? So let's try to bring the answer. 1.625 plus 0.25 in bracket f of 0. Idu appadi substitute pannunga. If I'll substitute here, this is going to be 0.5 and this is going to be what? 1 plus 625, right? If we add 0.5 with this, automatically it will become what? 2.025, right? So if I'll add, that is going to be, இவங்க ரெண்டு பேரும் அப்படியே ஆட் பண்ணுவீங்க. ஜஸ்ட் சப்ஸ்டியூட் 0.5 plus 1.625 ஆட் பண்ணீங்கன்னா என்ன வரும்? That is going to be 2.025. கரெக்டா? Yes. Let's reduce this function further. It is going to be 1.625 plus, can you cancel it? I think directly we cannot cancel. 0.5, yeah, 5625. That is the correct answer, right? So let's add these two, right? Such that I'm getting 5, right? I'm getting 7, I'm getting 8, I'm getting 1. So we are getting 2.1275. That is the value of y3, right? Yes, we got the answer. So the question is y3 is what, and we got the answer. That is going to be 2.1875. That is how we are using Euler forward method. Clear? Yes. 2.15625. For which one, ma'am? Someone posted the answer. I don't know for which one. Did I make any mistakes in the calculation? Okay, no problem. If I did, you please correct it. Because I don't know for what if someone uploaded that the answer is 2.15625. Okay. If I did any mistake in the addition, you please correct it by yourself. Fine. Let's continue our discussion with the second method, right? So next we have to talk about modified Euler method, right? Yes. That is called implicit method, right? Now in modified Euler method, usually what we are doing, right? Same thing, right? I said there is no difference, big things, right? Operations, everything. But initially we have to do something. Initially what we have to do? Let's continue. Let's take the same question. Let me rub this one first. Yeah. F of x comma y. The function is given as x plus y. And initial value is given as y of 0 equal to 1. Clear? And step size for the function is given as h is equal to 0.25. Again we have to find the value of, let us find the value of y1 by using modified Euler method. Just we have to do one iteration. That is enough. Just we have to understand. Clear? Fine. Now what is the formula that we saw already, right? The formula that we had been observed is solution for this function. Let's try to bring the answer, right? Modified Euler method, that is yn plus 1 is equal to yn plus step size h into f of xn plus 1 comma yn plus 1. Already I had been told you, actually we are trying to obtain the value of yn plus only. yn plus 1 தான் நமக்கு வேணும். அப்போ இங்கே எப்படி உங்களால் yn plus 1 substitute பண்ண முடியும்? That's a problem here, right? Anyway, let's take the function here first. That is yn plus h into f of xn plus 1, right? Actually, இதை நம்ம எப்படி எழுதலாம்? See, it can be written as, we all know f of x comma y is equal to x plus y. Then f of xn plus 1 comma yn plus 1 can be written as what? In bracket, we can write like this, xn plus 1 plus yn plus 1. Is there any mistake? No, I'm correct, right? Now let's reduce the function yn plus, just to open up the brackets, it is going to be step size h into xn plus 1 plus step size h into yn plus 1, whereas in the right hand side also we have yn plus 1 only. Now see there, implicit means in the inner equation we will have the term is called yn plus 1. Now we have to reduce. Just bring this term to the left hand side such that it is become yn plus 1 minus h into yn plus 1 equal to yn plus step size h into xn plus 1. Now from here you can take yn plus 1 outside such that it is going to be 1 minus h equal to yn plus step size h into xn plus 1. Clear? Now from this you can continue further and finally you can obtain the solution for yn plus 1 also. Yn plus 1 is equal to, it is yn plus step size h into xn plus 1 upon 1 minus h. Clear? Now see there, do we have the correct relation? Yes. Now we can bring the equation answer for the next iteration. Actually the question is what? y1 is dash. Guys, did you understand what I have done here? There are nothing to understand. A equation is given to you. Just write this equation in terms of xn plus 1 and yn plus 1 and substitute this value here, and then from here collect all yn plus 1 term one side and then keep yn plus 1 in left hand side, pass rest of all terms to the right side. Finally, if you observe the new equation, your new equation will become the format. See, in this format my yn plus term, yn plus 1 had been collected one side, rest of people are lying in the right of side, that is right hand side. Now we are feeling happy, we can substitute whichever the variable that we want and we can bring the answer. Okay? Yes. Let's continue our journey with this. This is called modified Euler method and it's very fast and it is very accurate too. Clear? Yes. Let's continue our journey. Anyway, question is what? Yn, right? Y0 is given now. See there, initial value, two values are given. x0 is equal to 0. x0 is 0, then what about x1? If x0 is 0, then x1 will become what? 0.25. Why? Because initially 0 and then with the step size 0.25, automatically x1 will become 0.25. What about x2? 0.5. x3 0.75. x4 1 and then 1.25, 1.5, 1.75 and so on. What about y1? We have to find that one. Let's take this one. Actually, let me consider n equal to 0 once again because I am in need of y1. If I will replace n equal to 0, 0 plus 1 will become automatically y1 should be equal to n equal to 0 now. So this is become y0 plus step size h into x, n equal to 0. 0 plus 1 will become x1 upon 1 minus step size. Let's substitute. Where is y0? Y0 is, it is given now, this is, y0 is 1, right? So y0 is 1 plus step size is 0.25 into, what about x1? x1 is 0.25, right? So x1 also 0.25. Where is x1? Here, right? In the denominator, 1 minus 0.25. Clear? Now see that 0.25 into 0.25 will become what? So it will become 0. See, we can write like this 1 plus, guys listen, 0.25, 0.25. Now we can write like this 1 by 4 dot 1 by 4. Do I have any mistakes? Did I made? No, right? So 1 by 4 into 1 by 4 become 1 by 16. In order to get the clear idea, I am writing like this 1 upon 16. 1 minus 0.25 will become 0.75, or we can consider 3 by 4. Is it visible? I am just writing it. Yeah, I think that is visible. Let's continue our journey. Let me rub this portion. Oh, y3 and the 2.15625 last question. Okay, no problem. Just correct it by yourself. Fine. Let's continue our journey. Finally, what we got, if you take cross product, 1 plus 1 by 16 will become 16 plus 1, right? Divided by 16. In the denominator, we are getting 3 by 4. Now, denominator of denominator, right? So, let me cancel it. See there. 4 times of 4 will be 16, right? Such that 16 plus 1 will become 17, right? By 3 into 4. Both are in the denominator only, 12. So that is the correct answer for y1. It's over. Okay. So that is how we are using what? Modified Euler method. You can also continue your iteration further. If you want to obtain the value of y2, similarly, replace n by 1, find out the value of y2 and then y3, whichever the term that you want, you can just proceed. Clear? But anyway, that is not our task here. We have to understand the process. That is enough. Okay. Now let us take the third one. Next, what we are going to do? Let's take the same question with the same step size. I am not going to change anything here. Just my intention is you all have to understand. That's enough, right? We don't need to do anything beyond this because you will be tested for some worthless question. Even this first iteration is அவ்வளவுதான். உங்களுக்கு question வந்து என்ன கேட்பாங்கன்னா first iteration ஓட வேல்யூ கேட்பாங்க. Otherwise direct equation கேட்பாங்க. Modified Euler equation ஓட formula, because TRB TNEB time consumption is the matter for you, right? So you all know that one. So you don't need to be panic. Just understand the procedure. That is enough. Fine. What is the next one? Ranji-Gutta method. So we should talk about. Let's go ahead with the different methods, right? Yeah, first one. Anyway, I'm just going up with the general equation. I too know we have to take different equation for second order, third order, fourth order at all. I'm not going with that one. I'm just taking general expression and we shall proceed. Understand the procedure. Same type of functions will be given to you and you are requested to find the solution using Ranji-Gutta second order method, third order method, fourth order method. Just to do it and bring the answer. That's enough, right? Fine. So it is, let's take Ranji-Gutta second order method, right? So what we saw in second order method, already we have seen the formula, right? So let me let us write the solution. First, there is yn plus 1 can be written as yn plus, right? What we saw here, I put 1 by 2 in bracket. We have to consider k1 plus k2. Clear? Yeah, that's correct. Let's take our target is, for an example, same question, y1 is what? If y1 is what, in the sense I will have to replace n equal to 0 such that it is become 0 plus 1 will become y1 is equal to y0 plus 1 upon 2 k1 plus k2. That is the solution. Now our target is y0 is known but k1 k2 is not known. So you have to achieve the value of k1 and k2. Let's see how do I find the value of k1. K1 we all know, that is h into f of what we have done, x0 comma y0, right? Now what is the value of h? That is step size. It is given as 0.25, right? In bracket f of x0 is how much? 0. x0 is here, x0 is 0, comma what about y0? That is 1, right? So that is the answer for this one. That is 0.25 into f of 0 comma 1 is how much? 0 plus 1 will give you 1 only, right? So that is equal to 0.25, right? So we got the value of k1. Now let's try and bring the answer for k2. h into f of what I had been told you, x0 plus h comma y0 plus k1. Yes, let's continue our discussion with this. Step size h is equal to 0.25 once again, that is f of, the function is going to be f of x0 is 0, h is 0.25, so 0 plus 2.5 will become 0.25, comma y0 plus k1. y0 is how much? y0 is 1. What about k1? k1 is 0.25. k1 means previous iteration. We got k1 just now I found, so k1 is 0.25 plus y0 is 1, so 1 plus 1 plus 0.25 will become 1.25, such that if I'll substitute f of x comma y, this is f of x comma y, x is equal to 0.25, y is equal to 1.25, so 1.25 plus 0.25 will become 1.5, so I can directly replace this whole function by 1.5. So we can say that is 0.25 into, we can raise this one, that is we can write this one as 1.25, right? Yeah. So now what will be the answer here? We can write, see, 1.5 can be written as 3 by 2. Any mistake? No. 0.25 can be written as 1 by 4 such that it will become 3 by 8. We can just write 3 by 8. That's enough, right? So we also found the value of k2, that is become 3 by 8. Let's substitute those two values here in order to find out the solution. That is going to be y0 is how much? 1. Already it was given, plus 1 by 2. What is the value of k1? k1 is 1 by 4 because 0.25 is equal to 1 by 4 only. So we can substitute 1 by 4 plus what about k2? 3 by 8. 3 by 8. Let's reduce this function in order to bring the answer. So let us rub this one now. I hope class is going good. See how easy your maths mathematics, right? Nothing is there. Just you have to understand and you have to apply, right? Automatically you bring the answer. Yeah, let's proceed. Just 1 plus 1 by 2 in bracket. Shall we take the LCM? I am just taking numerator multiplied by 2, denominator 2 into 4 will become 8, such that 3 plus 2 will become 5 upon 8. Clear? Now such that I am getting 2 into 8 becomes 16 automatically. 16 plus 5. See, anyway, let me write step by step. 5 upon 16 we can write like this, and then 16 plus 5 upon 16, such that 16 plus 5 become 21. So 21 upon 16 is going to be the correct answer for y1. Clear? Because you are requested to find out the value of y1 only. Let's try and do the same thing by using rest of two people, right? Rest of means Rangekuta third order and fourth order equations, right? Let's rub these things. Let's take third order and we shall try to find the solution. And we will take fourth order also. We shall try to fourth order formula and we shall try to find the answer. Okay. Yeah. Now take the third order method, right? I hope things are clear to you all. So you no need to wait for me. You can just proceed by yourself and you can find the answer. See, I am writing third order, right? Fine. Let's bring the answer. In third order equation, what we have to do, once again, we know the formula. What is the formula? Yn plus 1 equal to Yn plus, once again, step size h into f of. Once, guys, please forgive me. My mind is traveling along with the Euler forward method, right? So, okay, we are in third order. So, in Rangekuta third order, what I have done, that is 1 upon 6. We should put 6 in bracket, that is going to be k1 plus 4 times of k2 plus k3. Yeah. Now let's proceed further. We have to obtain the value of y1 such that I am replacing n equal to 0. So it is going to be y1 is equal to y0 plus 1 upon 6 in bracket as usual. We have to find k1 and we have to find k2, we have to find k3. Yeah, it's over. Now what I have to do? Let's find the value of k1, k2, k3. How do I find the value of k1? That is h into f of, right? See, once again, already I wrote the formula, right? So initially we have to find out the value of x0, comma y0, right? So let's raise h is what? Step size 0.25, right? F of x0, comma y0. x0 is 0, y0 is 1. So 0 plus 1 will give you 1 only, such that which is equal to what? 0.25. 1 into 0.25. Now let's try and find the value for k2. So that is h into f of x0 plus step size h by 2 plus it is going to be comma y0 plus k1 upon 2. Clear? That is the formula. Let's try and find the answer. Step size h can be written as 0.25 and the function f in bracket x0 is 0. 0 plus h by 2. Already the value of h is 0.25. Now, if I divide it by 2, then what I will get, that is going to be, first value is going to be 0 plus, that is 0 plus 0.25 by 2. You are going to get 0.125. Yeah, comma, second person, y0 plus k1 by 2. See, what is the value of y0? y0 is 1, already we found, that is given, right? y0 is 1 plus k1 is 0.25 divided by 2. 0.2 divided by 0.25 divided by 2 will be 0.125 plus 1 is going to be 1.125. 1.125. Again, if you add, see there, if I substitute, for x we have to substitute 0.125, for y we have to substitute 1.125, such that 0.125 plus 1.125 will become what? 1.25, right? So the answer is going to be, for this function, here you are going to get 0.25 into 1.25 only. Again, you are going to get the same value, right? So anyway, let's keep calci with us in order to avoid the mistakes, right? Let me open the calci. Yeah. So we are getting what? 1.25 into 0.25 is going to be 0.3125. That is the value for K2, right? Now we have to repeat to find out the value of K3, step size h, f of what I wrote, x0 plus h, comma, y0 plus k2. Exactly, that is correct. It is equal to, step size is 0.25, bracket in function, right? X0 is 0 as usual, there is no changes, plus step size is 0.25, right? So the first value is going to be 0.25. What about second value? Y0 plus k2. Y0 is 1, k2 is 0.3125, so that is going to be 1.3125. Right, now we have to substitute these two values into the function. 0.25 plus 1.3125, what I will get? So let me write the answer, which is equal to, right, so first we have 0.25 into f of x comma y can be written as, just to substitute, 0.25 plus 1.325 will give you 1.5625, correct? Exactly. Now 1.5625 into 0.25, I am getting 0.390625. Now after getting k1, k2, k3, our next target, we have to substitute all these values here. What is y0? Y0 is 1, already we know, 1 plus 1 upon 6 in bracket. What about k0? Sorry, k1, where is k1? K1 is 0.625, so k1 is 0.625 plus k1 is 0.625. K2 is how much? K2 is 0.3125, but we have to consider 4 also. 4 into 0.3125. Is that visible to you all? Oh, I just came out, right? Please wait, I have to go back. I think this portion is visible, right? Okay, fine. Let me write one more term. K3. K3 is how much? K3 is 0.390625. 0.390625. Yeah. Now that is perfect. Let us add all those things, right? Add pannunga. Plus we have to add 0.625 plus in bracket 4 into, I have to consider 0.3125, it's over. Then we should divide it by 6 and then we have to add with the 1, such that we are getting the next value 1.3776. Clear? So that is how we are solving the equation by using Runge-Kutta third order, right? Now I hope you all have understand the method, right? So I hope you all have understand. Now my intention is, I am just requesting you all to solve the problem, right? Take the same question, same data, try to bring the answer with the help of Runge-Kutta fourth order, right? That's my request. You please do it by yourself, because there are no new things in Runge-Kutta fourth order also. Same procedure, but except in the formula, instead of considering K2 alone, here we have what? 2 times of K1 plus 2 times of K2 plus 2 times of K3, and we have one more term K4, and I had given the formulas also, right? Everything I had given. Just derive that equation in order to find the answer. Find the value of y1, right? So that's what my request. Please do it by yourself and post your answer in the group, right? Fine, that's all. So this is how we are solving the problems based on, that is differential equations, how it is being solved with the help of Euler methods and Runge-Kutta methods, right? Fine. I hope things are clear to you all. Now see, same equation in your examinations also, you are tested with the same type of equations only. I found there was no big questions, right, from this area. I just solve பண்ண மாடலை விட ஈஸியாக தான் questions கேட்டிருந்தாங்க. So taking the questions, it's actually waste of time. So let's do one thing. Yeah. See, instead of going with that one, let me take the next one, right? Because your questions are easy, right? Not x plus y consider pandradhukku bala, they are considering only y, only x. Very simple question. Just you can solve it by yourself, right? Fine. Let's continue. Next, we are in the last part of the numerical methods, right? That is solution for linear equations, right? Already I had been told you, we are not going to learn any new things from here. Already we learned the basics of these methods in matrix, right? So in linear algebra itself, we got the methods, right? That is, we got the idea regarding this Gauss, that is Gauss elimination method, and I told you, we are going up with the lower upper triangular matrix, right? Method, that is decomposition method. That decomposition method is also called triangularization method, and is also called factorization method, right? So there are many names for that, right? And apart from that, I would like to discuss with you all that some other types, that is called Gauss-Jordan method and Jacobian iteration method, Jacobian matrix, right? Because I'm just giving some basics ideas. You know, I hope you all remember, till now, I did not touch one area in power system that is called power flow studies, right? Later, after completing the syllabus, I told you definitely I will touch that area. So trust me, I will do, right? If I'll say something, I won't leave that. Definitely, I will do it, right? So the thing is, I'm just giving introduction for that from here itself, because once you understand the procedure here, same thing, and we can directly develop that basic questions right there in our power flow studies, right? Fine. So let's start. There is the next part of our numerical method is, that is solution for linear equations, right? Now many methods are there, so let's take only very few methods, right, regarding our syllabus. Now first, right, so solution for system of linear equations, right? So just to keep the heading, we are looking for the solutions, right? Solutions for system of linear equations. Solutions for system of linear equations. So solutions for system of linear equations. Methods are very simple and you can simply understand, right? Anyway, let's explain. Let me explain all those things one by one. The first method that we are going to look now is called Gauss elimination method, right? So it's called Gauss elimination method, right? So Gauss elimination method. That is very simple method, right? So let me explain. In Gauss elimination method, how we are going to bring the solution for the system, right? So for the better understanding, I'm just going up with the 2x2 matrix only, right? Once you understand, you can play with your systems, right? Now for an example, a matrix is given to you. Shall we take 3x? That is better. Okay, let me take a 3x3 matrix for your better understanding, right? Let's take some small values like 1 1 1 2, like 3 1 1 and 1 2 3, right? So let us take some small values and let's try and bring the answer for this function. Actually, what we are going to do, we are going to find out the values of the vector variables, that is unknown variables, that is called the solution of system of linear equations. See, in our basic linear algebra, already we saw, right, where your system will going to provide unique solution, at which point your system will going to provide infinite solution. That things already we found. Now in this case, we are trying to exactly achieve the values of x and y, x, y and z's, right? So let's see, our target is we have to achieve the unknown values x1, x2, x3 or xy, z, right? Some people are writing xy, z, some people are writing x1, x2, x3, right? So whichever the terms that they are defining for unknown variables, just take those things. You don't need to be panic about that one, right? So let's consider 1 2 3. Clear? That is the given function. Now what is our target? Now we have to bring the answer. This is called the Gauss elimination method. See guys, that is very simple. In Gauss elimination method, you have to do only one thing. The thing is, just consider the diagonal principle, right? Go to the below of the diagonal principle. Diagonal principle கீழ இருக்க lower triangular மட்டும் choose பண்ணிட்டு அதுல இருக்க எல்லா வேல்யூஸையும் நீங்க 0 ஆக்கணும். At the same time, இந்த first value ஓட வேல்யூ வந்து 1 இருக்கணும். That's all. இங்க நீங்க ஃபர்ஸ்ட் செலக்ட் பண்ணிருக்க வேல்யூ வந்து 1 வரணும், ரைட்? அதே மாதிரி பிரின்சிபல் டயகனலுக்கு கீழ இருக்க லோயர் ட்ரையாங்கிளோட டோட்டல் வேல்யூவை 0 ஆக்கணும், ரைட்? So that is, for that, in order to do that one, we are going up with the elementary transformation. That is, we are going to do row transformations, right? That is element வந்து transform பண்ணி we have to do the that is we have to make this values as 0, right? இப்போ நம்ம என்ன பார்த்தோம், while finding rank find பண்ணும்போது I taught two methods, right? So first we were going up with the determinant. Second method நம்ம என்ன பண்ணிருப்போம், we are starting from the first column of last row. We should make this first value as 0 and then proceed further. This is the second value, you have to make this one as 0 and then you have to make this one as 0, right? And with இங்க நீங்க first step இங்க 1 கொண்டு வரணும். மேட்ரிக்ஸ்ல வந்து you can change row and columns, rows வந்து rows வந்து நீங்க இன்டர்சேஞ்ச் பண்ணிக்கலாம், இல்ல காலம்ஸ் இன்டர்சேஞ்ச் பண்ணிக்கலாம், இல்ல ஒரு row வந்து நீங்க 2 or 3 ஏதாச்சும் something you have to do, right, in order to bring the 1 here. And then automatically your next step you have to consider இங்க lower triangular matrix எடுத்துக்கிட்டு, right, take your matrix, go to the last row first value, make that one as 0 and then select the preceding row first value, make that one 0 and again go to the second value of the last row, make that one as 0, such that you are getting the resultant solution automatically. அதுக்கப்புறம் அது முடிச்சிட்டீங்கல ஆன்சர் வந்துரும், right? There are no things to do beyond that one, right? So let us try and bring the answer for this given function. So here we have what, 1 2 3, right? So let me rub this one, let me write them once again. That is 1 2 3, right? I'm just considering 1 2 3. Okay, just we will keep. Shall we proceed further? Yes, first target in the value நீங்க 0 ஆக்கணும், right? So for that, first write your matrix in argument form, A and B. In the format எழுதிக்கோங்க, augmentation. That is called augmentation. And we all know how to write the augmented form. That is 1 1 2 and 3 1 1 and 1 2 3. With this we have to consider matrix B also 1 2 3. Once you write down this one, இது நீங்க எழுதி முடிச்சதுக்கு அப்புறம் என்ன பண்ணீங்கன்னா automatically now you can do. See there in the last row ல இருக்க first value நீங்க 0 ஆக்கணும்னு சொல்லிருந்தேன் கரெக்ட்டா? இப்போ எப்படி 0 ஆக்குவீங்க? Directly we can do, right? First row last row எடுத்துக்கிட்டா last row first row ல இருந்து subtract பண்ணீங்க அப்படினா automatically you will get the answer. Let me select the third row. Now what the operation, what type of operation that we are going to perform? I am just doing R3 minus R1. This is the operation that we are going to perform now, right? So see, let me write this one there. So the operation that we are going to perform. So the next step, let me write the answer here. First, let's fill it. And what we are going to do, select R3 and we are going to subtract R3 minus R1. That is the operation that we are going to perform now, right? Very simple, just understand that's enough, right? Now what we are going to do, just to subtract 1 minus 1 is going to be 0, last row, right? And then 2 minus 1 will going to be 1. And then 3 minus 2 will going to be 1. And then 3 minus 1 will going to be 2. Correct? Yes, last row. Rest of rows are remains identical. 1, 1, 2, 1. I am not touching rest of rows. And 3, 1, 1, 2. That's all. What is our next task? We have to make this one as 0. Very simple, very simple. Just you can do it within 2 or 3 steps. You can bring the answer, right? Let's see what happened now. And this is 1, 1, 2, 1. Yes. And second, in order to make this one as 0, இப்போ இந்த வேல்யூ நீங்க 0 ஆக்கணும் அப்படினா என்ன பண்ணலாம்? Shall you do like this? Let me select row 2 and row 2 வந்து 3 ஆல மல்டிபிள் பண்ணிக்கோங்க and then right row 1 3 ஆல மல்டிபிள் பண்ணிக்கலாம். See, let me do one thing. R3 minus 3 times of R1. This is the operation that I am going to perform. Is it visible to you all that I am doing? Yes, that is visible. Fine. So let's continue the operation here, guys. Listen, what I am going to do, R3 minus 3 times of R1. Anyway, R1 is identical, we are not touching. R3 we are not, last row. See, this is not R3, R2. Sorry, forgive me. So 0, 1, 1, 2. Now let's write. இப்போ first row நம்ம second row எழுதுறதுக்கு நம்ம என்ன பண்ணோம் அப்படினா first row 3 ஆல மல்டிபிள் பண்ணி we have to do the subtractions, right? Okay. First row இப்போ நம்ம 3 ஆல மல்டிபிள் பண்ணோம் அப்படினா இங்க என்னென்ன வரும்? 3 3 6 3. கரெக்ட்டா? Now let's do 3 minus 3 automatically will become 0. Yes. And then 1 minus 3 will become minus 2 and then 1 minus 6 will become minus 5 and then 2 minus 3 will become minus 1. Yes. Anyway, next, what is our next task? We have to achieve, we have to make this one as 0. Automatically we can do, right? How will you do that one? Let me do it, right? So let us rub this one. Third step. Now what I am going to do, yeah. So the next step is take the matrix once again. 1 1 2 1 0 minus 2 minus 5 minus 1. Now we have to touch the last row. See guys, listen, இப்போ நீங்க last row என்ன பண்ணணும்? Last row in the select these two rows because now in the value 0, that is 0, that will be fixed. திரும்ப அது 0 தான் வரணும், right? அப்ப அது 0 தான் வரணும் அப்படினா what I have to do, the thing is let me select இந்த வேல்யூ வந்து 0 ஆக்கணும். இந்த வேல்யூ வந்து நான் இப்போ இது 0 ஆக்கணும் அப்படினா see there, select the last row, right? So let us perform the operation like this. R3 எடுத்துக்கிட்டா just to multiply R3 by 2. R3 2 ஆல மல்டிபிள் பண்ணிட்டு இத அப்படியே R2 கூட ஆட் பண்ணிக்கோங்க. அப்படி ஆட் பண்ணீங்கனா என்ன ஆகும்னா 0 plus 0 will become 0 only, there is no changes. But now here what happened, இத நீங்க என்ன பண்ணிருக்கீங்க 2 ஆல மல்டிபிள் பண்ணிருக்கீங்கல, 1 into 2 will become 2. R3 row full 2 ஆல மல்டிபிள் பண்ணிக்கோங்க, 2 2, here this become 4. அப்படியே ரெண்டுத்தையும் ஆட் பண்ணலாமா, 2 minus 2 will become 0. Next 2 minus 5 will become, right? So see, we are just adding, that's all. So that is going to be minus 3. So 4 minus 1 will become plus 3. Anyway, what I had been told you in matrix A, let us break. We all know this is A and this is B matrix. Now in matrix A, our target is our lower, right? Lower triangular matrix has to be completely going to be 0. Clear? So in the mari kondu vandinga appadina automatically you will get the answer. Now from this, what is the conclusion? The conclusion is once it is become 0, then we can write the solution. எப்படி எழுதலாம் கவனிங்க, let me write the matrix separately. இப்போ நான் திரும்ப எப்படி எழுதுறேன்னா matrix A வை தனித்தனியா பிரிச்சுக்கிறேன். Matrix A is 1 1 2, I got 0 minus 2 minus 5 and I got 0 0 minus 3. With this actually we are considering our vector variables unknowns, right? X y z, right? And in the right side our matrix is going to be 1 minus 1 3. That is finally what we got after completing the Gauss elimination method, right? So at the end of this Gauss elimination method, now what we are going to do, get now just write down the expression 1 into x. Guys listen, இது அப்படியே எழுதுங்க, ஈக்குவேஷன் எழுதுறீங்க. எழுதுறீங்கன்னா என்ன வரும்? or otherwise let me do. இப்படி எழுதும்போது லாஸ்ட் ரோல இருந்து மேலே போங்க. see first லாஸ்ட் ரோக்கு எழுதுங்க. minus 3 into z equal to 3. so we can write minus 3 into z equal to 3. Do you am I correct? See that 0 into x 0, 0 into y 0, minus 3 into z minus 3 into z equal to last row, right? Last row will be 3. From this I can say z equal to 3 getting cancelled, z equal to minus 1. Yes, we got the value for z. Now let's select the preceding row from the last one. So preceding row enna irukka? 0 into x 0, minus 2 into y, so we can say minus 2y, and minus 5 into z equal to next minus 1. Now we know the value of z. Let us substitute minus 2y minus 5 into, actually z equal to minus 1 we got already, right? So what is the conclusion here? Minus 2y, minus of minus become plus 5 only, plus 5 அந்த பக்கம் pass பண்ணீங்கன்னா automatically will become once again minus 5. So minus 5 minus 1 will become minus 6. If I'll cancel, minus minus getting cancelled, and 3 times of 2 will become 6, automatically y will become 3. Clear? Yes, we got the value for z and y. Our next target is x. Now select the last one, right? So இப்போ last one எழுதுனீங்க அப்படின்னா x into 1 plus y into 1 plus 2 into z equal to last, this is equal to 1. Now we know the value of y. Y is how much? This is y is 3 and z is minus 1, such that what we are getting 3, 2 into minus 1 will become minus 2, 3 minus 2 will become 1, 1 automatically getting cancelled, such that x will become 0. Let me check it myself once again. 2 into minus 1 will become minus 2, 3 minus 2 will become 1, so 1 minus 1 will become 0, so the value of x will become 0. So the correct solution for the given function is x, y, z can be written as, right? So answer for the given function is, the value of x is 0, value of y is 3, value of z is minus 1. Yes, we got the solution. Yes, that is all about Gauss elimination method. Clear? Is there any mistake? No. Right, now let me explain the second method. Just should try to understand what is the procedure. What I have done here, just we have to take given matrix AB வந்து ஒண்ணா மெர்ஜ் பண்றீங்க. மெர்ஜ் பண்ணதுக்கு அப்புறம் மேட்ரிக்ஸ் A ஓட லோயர் ட்ரையாங்குலர், ரைட்? ஸோ லோயர்ல இருக்க ட்ரையாங்குலரை வந்து நீங்க 0 ஆக்கணும். ஃபர்ஸ்ட் ரோல இருக்க வேல்யூ வந்து 1 னு வெச்சுக்கோங்க, ஜஸ்ட் ஃபார் ஈஸி ப்ரொசீஜர், ரைட்? ஸோ இதை முடிச்சதுக்கு அப்புறம் ஃபைனலி அதை அப்படியே ப்ரொசீட் பண்ணீங்க அப்படின்னா லாஸ்டா இங்க எல்லா வேல்யூ 0 ஆயிடுச்சா, தட் இஸ் ஓவர். அண்ட் தென் ரைட் தி எக்ஸ்பிரஷன் ஃபார் xyz, you automatically will get the value of xyz, right? Then that is the solution for the given function. Now let us discuss about the second method, that is called Gauss-Jordan method, right? So the second method that I am introducing now is called Gauss-Jordan method, right? So let me remove this one, right? So just keep the heading, right? That is second we are going to discuss about Gauss-Jordan method. See, there is no big difference, guys. Listen, நான் இங்க இருந்து ப்ரொசீட் பண்ண போறேன். ஆக்சுவலா என்ன அப்படின்னா, in Gauss-Jordan method, right, we are not only supposed to make the lower triangular 0, right, you are also supposed to make the upper triangular matrices 0. That's all. That's all. This is called what? That is, we have to design, we have to bring diagonal matrix. Diagonal matrix na meaning enna? You will have elements only in the diagonal of the matrix. If elements are only lies in the principal diagonal, then that matrix is called diagonal matrix. Do you all agree with me? Yes. So in Gauss-Jordan method, again you will have to proceed the same elimination procedure in order to find the in order to bring the diagonal matrix, right? Now அப்ப நீங்க இதுல என்ன procedure follow பண்ணனும்னா same procedure. Gauss eliminationல நீங்க என்ன பண்ணீங்களோ இந்த procedure அப்படியே யூஸ் பண்ணி triangular matrix வரைக்கும் வரணும். இப்போ lower triangular வந்து கம்ப்ளீட்டா 0 ஆயிடுச்சு அப்படினா next step immediately you have to keep your target with the upper triangular. First make this value as 0 and then make this value as 0 and then make this value as 0. That's all. Right? So you will have to proceed with the same procedure, right? Now you have to follow, that is upper triangular matrix இப்ப நீங்க திரும்ப 0 ஆக்கணும், right? That is what your next target. So let me proceed further. So just keep the heading, that is Gauss-Jordan method. I am just requesting, guys listen, question உங்களுக்கு நான் கொடுத்திருக்கேன் இல்லையா, அந்த question அப்படியே எடுத்துக்கிட்டு step number 1, right? So first step we have to go up with the Gauss elimination method, make lower triangular matrix as completely 0. இந்த step வரைக்கும் நீங்க அப்படியே எழுதிட்டு and then again step number 2 னு போட்டு select the upper triangular matrix, repeat the same process in order to make this complete value as 0, right? So don't blindly, for time being I am doing these things directly here, but for your request, that is why I am just requesting you Gauss-Jordan method போட்டதுக்கு அப்புறம் திரும்ப அதே क्वेश्चन திரும்ப எடுத்து எழுதி ஃபர்ஸ்ட் வந்து Gauss elimination methodல நம்ம இந்த ஸ்டெப் வரைக்கும் வந்துருங்க. ஜஸ்ட் இந்த ஸ்டெப் வரைக்கும் வந்ததுக்கு அப்புறம் அப்படியே ஸ்டாப் பண்ணிட்டு மெத்தட் நம்பர் 2 அப்படினு ஸ்டெப் 2 அப்படினு போட்டு அப்பர் ட்ரையாங்குலரை டார்கெட் பண்ணி அதுல இருக்க வேல்யூஸ் 0 ஆக்குங்க, right? So let me continue. Let us select the upper triangular matrix, right? Very simple, right? There are no things to understand, right? Yeah, let us proceed further. Now keep your target. Same procedure you can use, but upper triangular matrix நீங்க 0 ஆக்கணும் அவ்வளவுதான். That is Gauss Jordan method, right? So let us proceed further. So let me try and figure out the answer for that one also. Now what we are going to do in Gauss Jordan method? Select the upper triangular matrix. Let's proceed further. See, our target is what? We have to make this 1 as 0 first. Actually we have 1 2 minus 5, right? So let me rub this zone first. 1 2 minus 5, right? So our target is what? We have to make this 3 value as 0. First let us keep our attention with this person, right? So let us make this one as 0. இப்போ நம்ம என்ன பண்ணலாம் அதுக்கு? Let me write second row update எடுத்துக்கோங்க. 0 minus 2 minus 5 minus 1, there is no changes in the second row. Third row 0 0 minus 3 3, there is no changes in the third row. But first row, first value is 0, there is no changes. But second value, I will have to consider the second value as 0. இப்போ நீங்க இந்த 0 மாத்தணும், right? அப்படி மாத்தணும் அப்படினா see sorry, first value is 1, sorry, okay, second value, இப்போ இந்த value 0 மாத்தணும். So for that what I have to do? Very simple, right? Either you can go up with this one or this one, right? So see, this thing is, இப்போ இந்த வேல்யூ 0 ஆக்கணும் அப்படின்னா ஐ ஹவ் ஒன்லி ஒன் பர்சன், இந்த பர்சன் தான் எங்கிட்ட இருக்கார், ரைட்? ஸோ இதை வச்சு தான் நீங்கள் இதை 0 ஆக்க முடியும். அதாவது இந்த ரெண்டு பேருக்குள்ள தான் நீங்கள் என்ன பண்ணணும், ஆப்ரேஷன் பண்ணணும். ஸோ என்ன பண்ணலாம், ஆட்டோமேட்டிக்காக செலக்ட் ரோ R1, ரைட்? ஸோ R1 வில் பி மல்டிப்ளைட் பை 2, 2ஆல் மல்டிப்ளை பண்ணிட்டு ஜஸ்ட் ஆட் இட் வித் R2, கரெக்டா? am I correct? Yes. So அப்படியே ப்ரொசீட் பண்ணலாமா? இப்போ R1 நீங்கள் 2ஆல் மல்டிப்ளை பண்ணீங்க அப்படின்னா, ரைட்? if I multiply R1 by 2, such that 1 into 2 will become 2, 1 into 2 will become 2, 2 into 2 will become 4, இங்க 2 into 1 will become 2, கரெக்டா? Yes. Let's proceed. அப்படியே ரெண்டுத்தையும் ஆட் பண்ணுங்க. Now if I'll add these two, 0 plus 2 will become 2, right? So in the first value here we are going to get 2. Second value minus 2 plus 2 will become 0. Yes, happily we are getting. And then minus 5 plus 4 will give you minus 1. Yes, minus 1 plus 2 will give you plus 1. Yes, we got the value. Now what is our next task? One value become 0. Now immediately I have to make this value as 0. இப்போ அடுத்து இந்த value நீங்க 0 ஆக்கணும். That is what your next task, right? So in order to do that one, what I have to do? Let me go ahead. Guys listen. இப்போ நான் வந்து second row கூட போக முடியாது. இப்போ அடுத்து இந்த value 0 ஆக்கிறதுக்கு I cannot go up with the second row. Why? Because listen. இப்போ நீங்க இப்போ இந்த value 0 ஆக்கிறதுக்கு நீங்க என்ன திங்க் பண்ணுவீங்கன்னா, சார் இதை வந்து 5ஆல மல்டிப்ளை பண்ணிட்டு இந்த ரெண்டு ரோவையும் சப்ட்ராக்ட் பண்ணா 0 ஆயிடும் நீங்க யோசிப்பீங்க. இப்போ இதை 5ஆல மல்டிப்ளை பண்ணிட்டு இந்த ரெண்டு ரோவையும் சப்ட்ராக்ட் பண்ணும்போது இங்கேயும் சப்ட்ராக்ட் பண்ணுவீங்கல்ல, அப்போ this value again will become not equal to 0, right? Because 0 minus of minus 2 will become plus 2, again 0 plus 2 will become 2. அப்ப நீங்க திங்க் பண்ணணும், எந்த வேல்யூ வச்சா இந்த வேல்யூ, see இந்த வேல்யூ 0 அப்படியே கண்டினியூ ஆகணும், as well as இந்த இடத்துல வேல்யூ வந்து 0 ஆகணும். அப்ப நம்ம இந்த ரோ கூட போக முடியாது. Instead of go with this one, we can go with this one. இப்போ இந்த ரோ கூட போனீங்க அப்படினா 0 plus 0 will become 0 only. So there is no changes in this one, but here we can change the answer. So you should think and then you have to do, right? So in order to make this value as 0, let's perform the operation with row 3, right? So let's take the matrix now. First row we are going to change, second row 0 minus 2 minus 5 minus 1, right? Last row will become 0 0 minus 3 3, right? So let's take the first row. Guys, I told you, I'm repeating once again, second row கூட நீங்க ஆபரேஷன் perform பண்ணீங்க அப்படினா, for an example இங்க 0 இருக்கு, இப்போ இந்த ரெண்டு ரோவை நீங்க ஆட் பண்ணும்போது இந்த வேல்யூ இந்த இடத்துல என்ன வரும்னா திரும்ப we are getting not equal to 0 value, right? But I am in need of, I have already நம்ம 0 ஆக்கியாச்சு, நம்மளோட டார்கெட்டே அது 0 ஆ இருக்கணும்ன்றதான். So we cannot perform the operation with row 2, you will have to perform the operation with row 3 such that if you add these two value again you are going to get 0 only, there is no changes in this value. I hope things are clear to you all, right? Let's continue our journey with this. அப்ப first row நம்ம என்ன பண்ண போறோம்? So here the operation that we are going to perform now is called select R1, right? And I am multiplying it by 5 times of R1 and I am going to subtract it with from R2, sorry R3 or என்ன பண்ணனும் 3 ஆல மல்டிப்ளை பண்ணனும், sorry guys. ஃபர்ஸ்ட் ரோவை 3 ஆல மல்டிபிள் பண்ணிட்டு அதை அப்படியே சப்ட்ராக்ட் பண்ணிக்கோங்க. எங்க இருந்து? R3 ல இருந்து we have to subtract, right? Or you can do one thing, ஃபர்ஸ்ட் ரோவை நீங்க -3 ஆல மல்டிபிள் பண்ணிட்டு டைரக்டா ஆட் பண்ணிக்கலாம். -3 times of R1 plus R3. உங்க மைண்ட்ல என்ன தோணுதோ அதை ஃபாலோ பண்ணிக்கோங்க, ரைட்? See, இப்போ இத ஃபர்ஸ்ட் ரோவை -3 ஆல மல்டிபிள் பண்ணீங்கன்னா இங்க வேல்யூ என்ன வரும்? 2 into -3 will become -6, 0 into anything 0 only, so that is 0. -1 into -3 will become +3, 1 into -3 will become -3. Let's add these two people. இப்போ ஆட் பண்ணீங்கன்னா see that what you are getting 0 -6, right? So if I add 0 -6, it will become -6. And then 0 minus 0 automatically will become 0, and then -3 plus 3 will become 0, and then 3 minus 3 will become 0. 3 minus 3 will become 0. Anyway, matrix B, I don't want to bother. Our target is we have to achieve இவங்க மூணு பேரை 0 ஆக்கணும். That is your target. right? So அவங்க மூணு பேர் மட்டும் தான், that is upper triangular matrix value has to become 0. Let's continue our operation. Still one more step is there, right, to do. So let us continue. -6 0 0 0. Yes, now our target is second row. So I am just stopping second row அப்படியே வச்சிட்டு let's continue our operation. Second rowல இந்த -5 0 ஆக்கணுங்க. இப்போ என்ன பண்ணலாம், again second row இந்த வேல்யூ 0 ஆக்கணும்னா இங்க தான் வேல்யூ இருக்கு. I cannot do anything with 0. so இவங்க ரெண்டு பேர்ல தான் நம்ம ப்ளே பண்ணோம். என்ன பண்ணலாம், so take this row multiplied by 3, take this row multiplied by 5 and then do the subtraction. Am I correct? Yes. Now what I am going to do, so I am performing the operation, right? So we are just performing the operation with the R2. Is that visible, guys? I am just writing these things without seeing. Yeah, that is visible. I am really very happy. So let's take the second row. Second row நம்ம 3 ஆல மல்டிப்ளை பண்ண போறோம், right? So let me do one thing. I am just multiplying it by -3. So -3 times of R2 we are performing and then plus 5 times of R3. That is enough. இப்போ இதை மல்டிபிள் பண்ணால் என்னங்க வரும், இந்த ரோவை 3 ஆல் மல்டிபிள் பண்ணிங்கன்னா it will become 3 into 0 0. இதை 3 ஆல் மல்டிபிள் பண்ணால் -3 ஆல் மல்டிபிள் பண்ணுறோம். -3 into -2 will become +6. -5 into -3 +15. -1 into -3 +3. Last row 0 0. 5 times of -3 -15 and then 3 times of 5 will become +15. Shall we continue our operation? Of course, right? So let's see. அதுக்கப்புறம் என்ன பண்ணணும், ரெண்டு ரோவை ஆட் பண்ணணும். 0 plus 0 will become 0. 0 plus 6 will become 6. -15 plus 15 will become 0. 15 plus 3 will become 18. Automatically it will become 18. Of course, right? Now that's all. It's over. After completing this one, see there. Now happily we can say, sir, lower triangular matrix will become completely 0 as well as upper triangular matrix also will become 0, sir. Yes, that is called Gauss-Jordan method, right? Once you found the diagonal matrix, then getting back, right? So let us break this one. தனித்தனியா எழுதுங்க, matrix A, matrix B எழுதிட்டு let's write same x y z நம்ம find பண்ணோம். That's all. It's over, right? So that is how we are solving the system, right, with the help of Gauss-Jordan method in order to find the solution, right? So let me rub this one. Let's try and figure out the answers, right? Now matrix A, what we got? So matrix A can be written as -6 0 0 0 6 0 0 0 -3. With this here we have to consider x y z, of course, which is equal to, here we are going to consider 0 8 3. Yeah, shall we write down the answer now? Yes, see there, guys. 0 into x 0, 0 into y 0, -3 into z equal to 3. What is the answer? Z equal to -1. Z equal to -1. Second thing, 0 into x 0, 6 into y 6y, 6 into y 6y, and then equal to what? 8. 6 into y is equal to 8, right? Such that what is the value of y? So here automatically we will get the value for y. So y is going to be what? You can cancel it. 4 times of 2 will be 8. 3 times of 2 will be 6. Such that the value of y will become 4/3, right? Now what is the value of x? See there, -6 into x, 0 into y 0, 0 into z 0, -6 into x equal to 0. Automatically x will become 0. Yes, x will become 0. See, that is how we are obtaining the solution for x, y, z, right? X, y, z with the help of Gauss-Jordan method. So our answer is 0, 4/3 -1. See, listen, just to understand the procedure. If I made any mistakes in the addition subtraction, you just correct it by yourself. That's not the matter here, right? You have to understand the procedure. Now what is the Gauss-Jordan? This is Gauss-Jordan method. I hope things are very clear to you all. What is our next task? Let's learn some other methods. I said this is two methods in order to find out the solution. We got two methods. One is Gauss elimination method and second one is Gauss-Jordan method, right? So let us demonstrate the third method, that is called factorization method. We are also calling it as lower triangular, that is lower triangular upper triangular decomposition method, right? So that is also called a triangularization method, right? So let me take that one and I will demonstrate, right? So let me demonstrate that one also. So let us remove this one first. Let us remove this one, right? Yeah. So the next method is LU decomposition method, right? So the next method is LU decomposition method. So let me rub this one. Let me demonstrate, right? So the next one is LU decomposition method, right? Decomposition method. It is also called factorization. It is also called factorization method. It is also called triangularization. It is also called triangularization method, right? So there are three names for this method, right? Fine. Let's start. It's very simple. There are no big things to understand. In order to demonstrate this one, let us take a simple 2x2 matrix. That's enough, right? Yeah. Now, for an example, a matrix will be given to you, right? That matrix, let us consider A11, A12, A21, A22. That is the given matrix, and with this, a vector variable is defined as xy, and then corresponding matrix B will be given, that is B1, B2, right? Let us assume that is the given matrix. Now, this is in the form of what? Ax equal to B, correct? Of course, that is non-homogeneous equation. We all know. Now, we have to write this, factorize. This is matrix A. This matrix A will be decomposed. That is called decomposition in the form of lower and upper triangular matrix, right? So, which is equal to L into U, right? So, first step, we are going to factorize the matrix A. Appadina meaning enna? So let me demonstrate, which is equal to, it means this matrix A can be rewritten as, idu nam eppadi eludha porona, A11, A12, A21, A22, just it will be factorized, right, such that lower triangular matrix will become, right? Ipo nam endha formula eludha porona, guys listen, 1 1, always consider the diagonal values of the lower triangular matrix as 1, such that let us consider L21, that is L21 only na. So that is going to be 1, and this is going to be 0. In lower triangular matrix, upper value is always 0. Principal diagonal ku மேல இருக்க value எப்பவுமே 0 இருக்கும். எதுல? lower triangular matrixல. அதே மாதிரி lower triangular matrix ஓட diagonal values set this values as 1, right? And just method, right? And upper triangular matrix we can write like this. What shall we consider? Upper U11, let us consider U12, and then it is going to be 0, it is going to be U22. Clear? That is upper triangular. Am I correct? Upper triangular matrix na principal diagonal ku மேல value வரும், கீழ வராது, right? Lower triangular na principal diagonal ku மேல வராது, கீழ வரும், right? And one more thing is, in lower triangular matrix, this diagonal value is always 1. That's all. These are the things that you have to remember in your mind. Let me repeat once again. Take your matrix, decompose your matrix in the form of lower and upper triangular, right? This is the that is discovered methods, right? So அப்பதுல என்ன பண்றீங்க அப்படினா, either one matrix, ஒரு matrix வந்து நீங்க என்ன பண்றீங்கன்னா, principal diagonal of a matrix is going, that is lower triangular matrix, we are setting as 1. ஒரே ஒரு இதுல மட்டும், இது ரெண்டுத்துல ஒரு மேட்ரிக்ஸோட diagonal values வந்து 1 ன்னு செட் பண்றீங்க, right? So let me set this one as 1 1, right? So lower triangular matrix க்கு 1 1 செட் பண்ணியாச்சு, and here we don't have, right? I don't know the variable, we have to find upper triangular values, sorry, lower triangular matrix க்கு principal diagonal க்கு மேல ஆட்டோமேட்டிக்கா 0, upper triangular matrix க்கு principal diagonal கீழ ஆட்டோமேட்டிக்கா வேல்யூ வந்து 0 ஆயிடும். That's all. Same procedure you can follow for 3x3, 4x4, 5x5, for all type of square matrix, right? Now, so this is our target. So இத பண்ணி முடிச்சதுக்கு அப்புறம், right? So next step, so let me explain. So in the process மட்டும் நீங்க மைண்ட்ல வச்சுக்கோங்க. Now let us take some example. Let me demonstrate how to bring the answer with the help of this decomposition method, right? So this is the basic method, right? So let's take some example, because always our mind is understanding these things with examples only, right? Theoretically always our mind is won't having, that is it won't capture the exact ideas, right? Let's take some example in order to get the clear idea. 1 2 3, let's consider 4. I have a matrix. Let's consider its corresponding vector variables x and y. Once again, we have to find the solution for x and y only, but we are going up with some different method, and let us consider matrix B has certain values 2 and 3. Just to take some example, that's enough. Now just we have to collect the matrix A outside. My matrix A is 1 2 3 4. This is our matrix. Exactly, that is correct. This matrix had been decomposed as upper and lower triangular form. In lower triangular, first we have to consider lower triangular, right? In lower triangular, diagonal principle is 1, and here we are going to consider lower means L21. Let's consider L21, and here it is going to be 0, we all know. And upper triangular matrix can be written as upper U11, U12, 0, U21, right? Such that now what we are going to get, just guys listen, இது அப்படியே reduce பண்ணுங்க, reduce பண்றது அப்படினா we know how to do matrix multiplication, right? Select the first row, multiply with the first column, select the first row with the second column, second row with the first column, second row with the second column. That is the matrix multiplication operation. Let's continue our operation in order to reduce these two matrix. First இவங்க ரெண்டு பேரும் multiply பண்ணுங்க. 1 into u11 plus 0 into 0 such that you are going to get only u11. Next 1 into u12 plus 0 into u21 such that you are going to get only u12. Next L21 into u11 plus 1 into 0 such that you are going to get L21 into u11 only. Next L21 into u12 plus 1 into u21 such that here we are going to get L21 into u12, let me write u12 plus 1 into u21, that is u21. That's all. Now and then you are supposed to do the comparisons, right? So என்ன comparison பண்ணீங்கன்னா just இந்த ரெண்டு மேட்ரிக்ஸை கம்பேர் பண்ணுங்க. ரெண்டு பேரை கம்பேர் பண்ணீங்கன்னா இங்க என்ன தெரியுதோ u11 equal to 1, yes, u12 equal to 2, yes, right? So let me find out the answer. u11 equal to 1 and then u12 equal to 2. Next அப்ப இவங்க என்ன வருவாங்க, L21 into u11 equal to 3. Exactly, but we know the value of u11. What is the value of u11? That is 1. If I substitute u11 by 1 such that L21 will become 3. Next select the last one, L21 u12 plus u21 equal to 4. Exactly. Here what about the value of L21, which is there is 3. What about u12? That is 2. This is 2. What about u21? We have to find by using this one such that what is this, 3 into 2 will become 6. 6 அந்த பக்கம் பாஸ் பண்ணீங்கன்னா automatically u21 will become -2. Yes, we found the value of u21, u22, right? Sorry, u22 is not, see I think here I made mistake, right? So where is the, guys, this is u22 only na, why I wrote this one as அப்ப நம்ம இங்க எங்க வரணும், this is u22 ah, yes, this is u22. வேற எங்கேயாச்சும் அது வந்திருக்கா பாருங்க, நோ, வேற எங்கேயும் வரல, ரைட்? வந்திருந்தா கரெக்ட் பண்ணிக்கோங்க. that is u22, sorry, that's my mistake. Fine, so this is going to be u22 only. So u22 equal to -2. Yes, we got the value for upper and lower triangular matrix, right? So let us substitute the values here. அப்ப L21 ஓட வேல்யூ எவ்வளோ, first of all L21 is 3 first, and then u11 எவ்வளோ, u11 is 1, u12 எவ்வளோ, u12 is 2, u22 எவ்வளோ, u22 is -2. Yes, so first thing in your examination, இந்த மாதிரி இருக்க ஒரு மேட்ரிக்ஸை டீகம்போஸ் பண்ணி you are requested to find the lower triangular matrix or upper triangular matrix. இதில் ஏதாச்சும் ஒரு மேட்ரிக்ஸ் உங்ககிட்ட கேட்பாங்க. You will be tested for this one, you will be tested for worthless 2 mark question, right? Because it is you are spending some time now, so that is what actually if you don't remember then it is worth for 2 mark, but if you remember that is not worth for even 1 mark, right? So just you have to take that matrix, you have to write it in the upper and lower triangular format, and then அது உள்ள மல்டிபிள் பண்ணீங்க அப்படினா you will get this one, right? And then do the comparison, you will get the answer. Over. Clear? So that is how we are doing the decomposition. Anyway, our target is this is not we have not completed yet. After finding these variables, we have to achieve the value of x and y na. So what I have to do, let me take this one. Let's continue further. Let's continue, right? Anyway, in your examinations you are not supposed to go with the final answers, right? You are supposed to இத தான் பண்ண சொல்லுவாங்க எக்ஸாம்ல, right? Decompose மட்டும் தான் நீங்க பண்ணணும், because that is the different one, right? So rest of process at all remains same. It is as same as our previous methods. After finding this one, what I have to do, அப்ப மேட்ரிக்ஸ் A வை வந்து இப்போ நம்ம இப்போ எப்படி எழுதிக்கலாம் அப்படின்னா, guys listen, மேட்ரிக்ஸ் A வந்து நம்ம எப்படி எழுதலாம்னா 1 0 in terms of upper and lower triangular format we can write 1 0 3 1 instead of considering matrix A. Alright, after factorizing this one we can write like this 1 2 0 -2, that is lower and upper triangular matrix. Now with this we can write your variables x and y which is equal to, இங்க நம்ம என்ன கன்சிடர் பண்ண போறோம்னா we are going to consider our matrix B. Guys, actually I forgot the variables for matrix B that I took. I'm just writing some random variables. If I'll make any modification here, please you please correct it by yourself, right? Because I forget, I don't know what variables that I took there. Okay, let's continue our journey with this. Yeah, so next our next target is, so let's rub this one. Okay, listen, how I'm going to get the solution for this system, right? You might be wonder, right? Now what I would like to tell you now, see, listen, இப்போ நீங்க என்ன பண்றீங்க அப்படின்னா first இந்த மேட்ரிக்ஸை தனியாக எடுத்துக்கோங்க. இந்த whole thing இருக்குல்லையா, இந்த மேட்ரிக்ஸ் வந்து நான் எப்படி எழுதுறேன் அப்படின்னா, see there, let me write like this, எப்படி எழுதலாம்? This is lower triangular, right? This is upper triangular and this is our vector variable. Let me call u into x. நான் இப்போ இந்த வேரியபிள் மட்டும் என்ன பண்ணுறேன் அப்படின்னா yக்கு வந்து ஈக்குவேட் பண்ணிக்கிறேன். Just I'm equating this variables to y, right? Let's see what happened. இப்போ இதில் u ஓட வேல்யூ என்னது? upper triangular matrix ஓட வேல்யூ வந்து 1 2 0 minus 2 exactly, right? With the variables that we are considering here, right? I'm just considering x y. Let's consider x and y. Of course we are going to consider x and y, and I am just equating this one with I'm just equating this function to y1 y2. I'm just equating this function to y1 and y2, right? So let's see what happened. Just do you understand what I am getting? இது ரெண்டுத்தையும் சால்வ் பண்ணா எனக்கு ஒரு வேல்யூ வரும், அதை நான் y1 y2 அப்படின்னு எடுத்துக்கிறேன்னு சொல்றேன், right? Such that so if I will reduce this one, what I will get? 1 into x we are going to get x only, plus 2 into y we are going to get 2y. Such that 0 into x we are going to get 0, plus minus 2 into y, so we are going to get minus 2 into y, which is equal to what? This is equal to y1 and y2. That is equal to y1 and y2, right? So what is the conclusion here? Let us substitute. அப்போ நான் என்ன பண்ணிக்கலாம், இந்த total termக்கு பதிலா I am just considering y1 and y2, such that what we are going to get? You are going to get 1 0 3 1, and here the variables that we are going to consider now is y1 and y2 only, right? Equal to, because this whole matrix can be replaced by y1 and y2, right? So I am correct. So next what we are going to get? You are going to get 2 and 3 here. If you solve these two expressions, what you are going to get? 1 into y1, yes, 1 into y1, plus 0 into y2, yes, of course, that is 0 into y2 will become 0 only, so we can consider 0, equal to what? That is equal to 2, such that y1 equal to 2. Similarly 3 into y1 plus 1 into y2 equal to 3. We got two equations. Here also we got two equations. இதில் நீங்கள் என்ன எழுதுவீங்க? y1 can be written as x plus 2y. Yes. y2 can be written as minus 2y. Correct? Yes. y2 can be written as minus 2y. Right? So let's solve these two equations in order to find the value of x and y variables. Right? So let me rub this one. Do you understand what I have done? நான் என்ன பண்ணியிருக்கேன்னா, first one is lower triangular matrix. Next one is upper triangular matrix. But இது நம்ம டைரக்டா அப்படியே சொல்யூஷன் கொண்டு வர முடியாது இல்லையா? அப்போ நான் இந்த ரெண்டு பேரை மட்டும் தனியா எடுத்து அவங்கள வந்து நான் y1 y2 கன்சிடர் பண்ணி ஃபர்ஸ்ட் சால்வ் பண்ணிக்கிறேன். அப்போ இந்த ஹோல் பர்சன்ஸ் ரீப்ளேஸ் பண்ணிட்டு y1 y2 கன்சிடர் பண்ணி இதை சால்வ் பண்ணி ஒரு ஈக்குவேஷன், ரெண்டுத்தையும் சால்வ் பண்ணீங்கன்னா you'll get the answer. This is the method in order to find out the variables of x and y. Clear? I hope things are very clear to you all. Anyway, finding the answer is my part, right? So let me complete that one also quickly, right? Let's bring the final answer. Finally what we get here, listen guys, இங்க y1 equal to x plus 2y, இங்க y1 equal to 2. இது அப்படியே ரெண்டு பேரையும் கம்பேர் பண்ணீங்கன்னா what you are getting? x plus 2y equal to 2. That is what I got. Second, இங்க y2 is equal to minus 2y. See, select this one. இங்க எனக்கு என்ன வந்திருக்குன்னா 3 into y1 can be replaced by, டைரக்டா இதை சப்ஸ்டிட்யூட் பண்ணிக்கலாமா? y1 க்கு பதிலா we can substitute 2, y1 க்கு பதிலா 2 சப்ஸ்டிட்யூட் பண்ணிக்கலாம், plus y2 க்கு we can replace this one, right? So y2 is what? Minus 2y. y2 is minus 2y equal to 3, right? It's equal to 3. I'm just solving the second equation 3 into y1. You might think, sir, y1 க்கு பதிலா இதை சப்ஸ்டிட்யூட் பண்ணலாமேன்ட்டு. Why are you unnecessarily wasting your time? We know the value of y1 directly, we can substitute. And then y2 is here, and you can substitute y2 here such that you are directly getting the value for y. 3 times of 2 will become 6. 6 அந்த பக்கம் பாஸ் பண்ணீங்கன்னா minus 2y equal to 3 minus 6 will become minus 3, such that minus minus getting cancel, y is equal to, you are going to get what? 3 by 2. Yes, we got the value for y. Once you get the value of y, automatically you can also get the value for x. அப்போ x க்கு வேல்யூ என்னங்க வரும்? x plus 2 into value of y is, that is 3 by 2, 2 getting cancel, equal to 2. Automatically x equal to, இங்க 3 இருக்கா, அந்த பக்கம் 2 இருக்கா, 2 minus 3 will give you minus 1. What is the answer? X equal to 3 by 2, x equal to minus 1, y is equal to 3 by 2. So the vector variables x and y, its correspondent solutions are going to be, simply we can say the value of x is minus 1 and the value of y is 3 by 2, and the value of y is 3 by 2. Clear? That is how we are getting this solution. I hope things are very clear to you all. Guys, please do remember this factorization method, because in your examinations, right, you will be requested to find out the value of lower triangular and upper triangular values, right? That is very important. At sometimes that you will be tested for 2 more questions. That is not 1 mark, right? So please do remember the procedure. That is enough, right? Fine. So let me rub these things. Yeah. See, in the vector variables நம்ம வேற எப்படி ஃபைண்ட் பண்ணலாம்? in our matrix we saw a method that is called eigenvalues eigenvectors, correct? That is one more approach. By finding the eigenvalues, right, with the help of eigenvalues also we can find out the eigenvectors, right? Fine. So let's rub this one. The next target is we are going up with the Jacobian matrix, right? I told you there is the next method is called Jacobian matrix, right? So let me explain that one also. Let's see Jacobian matrix, right? Now what we are usually doing in Jacobian matrix, right? So for the next one we are going to look at now is called Jacobian matrix. I'm just giving the introduction for power system, right? Power flow studies, right? So that is Jacobian matrix. Just to remember, at last I will touch the portion of your what I can say load flow studies. Okay, fine. So let's continue Jacobian matrix. It's very simple, right? It's very simple. Actually Jacobian matrix that is once again it is helping us in order to find out the solution for nonlinear equations, right? Nonlinear equations, for an example, if I have a variable like this, for an example I have a matrix e power x, right? I'm just having a variable like this, e power x1 plus x1 square, x2 square. I have a variable like this and it was being equal to 0, and I have one more variables, right? So x2 square, okay, let us do one thing. I have x1 square plus, right, and I have one more variable like x2 equal to 0. Now for this type of equations, right, we can solve this type of nonlinear equations. Can you solve them directly? Please tell me, how do we solve this one? That's not possible. We cannot solve this, right? So but this type of equations can be solved with the help of Jacobian matrix, right? So let's proceed. Now the thing is they are given two functions. Do you all agree with me? First thing, this function can be written as f1 of x. This is f1 of x, that is e power x1 plus x2 square. Similarly, second function, let me write f2 of x, right? This can be written as x1 square plus x2. Take these two functions. Clear? இப்போ நீங்க என்ன பண்றீங்கன்னா your target Jacobian matrix. Let me write the Jacobian matrix J of x. Jacobian matrix generally can be written as, right? So in the first row we are considering, right? So just dou f1 by dou x1. First take your function 1, differentiate it with respect to variable x1, and then in the second person similarly dou f1, but now take the differentiation with respect to x2. Again in the first row, again continue, take the same function, differentiate with respect to x3, continue it until the arrival of final variable, right? So dou f1 by dou xn. See, in our case we have only two variables, but you will be tested for n variables, right? Similarly in the second row we have one more function, so adha eppadi eludringa, dou f2, let me write the general formula, dou f2 by dou x1, similarly dou f2 by dou x2, similarly dou f3 by dou x3, etc. You can raise this solution, right? You can go up to dou xn. Like that you can go up to dou fn, last variable, right? And you can do dou fm, let me consider like this, and differentiate the final variable with respect to dou x1, and dou fm differentiate with respect to dou x2, dou fm differentiate with respect to dou x3. Continue this until the arrival of dou fm, that is final value we are differentiating it with respect to xn, that is last variable. Clear? So that is the general form of our Jacobian matrix. I hope these things are very clear to you all. Now what is your next task? We have to obtain the solution for this one. Anyway in our case we have only two matrix, right? And initial values will be given to you, right? Just you are supposed to do the iteration only, right? நீங்க என்ன பண்ணணும் அப்படினா iteration பண்ணிட்டே இருக்கணும். என்ன iteration பண்ண போறீங்க? Just you have to substitute this value here in order to find out the next solution for this function, right? So for an example, anyway if you differentiate பண்ணி நீங்க Jacobian matrix ல வந்து represent பண்ணீங்க அப்படினா what you are going to get, right? You are going to get, so let us write the Jacobian matrix for our function. இப்போ நீங்க இதுக்கு என்னங்க எழுதுவீங்க? How many variables are there? Only f1 and f2 are there, and two variables are there. So two variables, two functions. அப்ப எப்படி எழுதுவீங்க? First function 1, I can differentiate this function 1 with respect to x1. I can do differentiation this function 1 with respect to x2 also. First case, and the second function will become what? Second function can be differentiated with respect to x1. Second function can be differentiated with respect to function x2 also. It's over. Clear? That's all. Now you are supposed to substitute the values. It's over, right? It's over with this. That is called Jacobian matrix form, right? Now என்ன பண்ணுவீங்க? Differentiate பண்ணி substitute பண்ணலாமா? Yes. Let me substitute the functions here. The thing is, see, you are requested to find out the what I can say Jacobian matrix values, right? With for an example, initial value will be given like this. Initial value வந்து என்ன கொடுத்திருக்காங்கன்னா x1 equal to 0. Let's take x2 also 0. Initial value will be given like this, and you are requested to find out the Jacobian matrix for the given function. Right now let us found the Jacobian matrix dou f1 with respect to dou x1. இப்போ இந்த function with respect to x1 differentiate பண்ணீங்கன்னா what will you get? E power x1 once again will become x1. Can you, if I am doing differentiation with respect to x1, x2 will become a constant, so differentiation of x2 will be automatically 0. Second case, now we have to differentiate this function with respect to x2. When we are differentiating this function with respect to x2, x1 will become constant, automatically x1 is going to be 0, such that your answer will become, if you do differentiation with respect to x2, you are going to get what? Twice of x2. Now continue again, f2 of x. If I will do differentiation this function with respect to x1, you are going to get 2 times of x1. If you are doing differentiation with respect to x2, you are going to get 1 only. Clear? Now and then you can substitute the initial variables that is given to you in order to find the solution for this function, right? Now if I will replace x1 equal to 0, then what will happen? E power 0 will give you 1. If I will replace x2 equal to 0, 2 into 0 will become 0, and then x1 is going to be 0, so 1 into 0 also will become 0, such that x2, so anyway last variable is 1 only, so we can consider, see, we are getting an identity matrix, right? Unfortunately, right? Yeah, so that is the solution, or that is how we are finding the solution for your given function with the help of Jacobian matrix. Guys, listen, you will be tested for this type of functions with the worthless questions, right? Only this type of simple equations will be given to you, and you are requested to find out the solution for this one. That's all, it's over, right? So this is called Jacobian matrix. Just do remember this one. I'm just giving introduction. In power flow studies, once again I will talk about this person with the same thing. I'm not going to tell you these new things I'm giving here. Already we saw in numerical method. This is Jacobian matrix. Just to keep these things with you, and in power flow studies I will tell you how to do some things beyond that. In power flow studies we have to look at some things in a new way, because we have to do analysis now. That things I will complete there, right? So don't be panic, just to make notes, very clear notes. That's enough. Yeah, this is all about Jacobian matrix, right? Same type of worthless questions will be given in your exam. Don't be panic, just do remember this one. That's enough. One step you will get 2 mark. You won't be tested for 1 mark, right? You will be tested for 2 mark, because you have to remember this procedure na? So it is worth for 1 more mark, right? Yeah, that is all about Jacobian matrix. Anyway, there is one more method that is called Jacobian iteration. I don't want to do that one, because that is iteration procedure, right? So with this, your numerical method is completely going to be over, right? See, there are very few questions yesterday I had collected, but நம்ம சால்வ் பண்ணதை விட they are very easy. Just நீங்கள் கொஷினை பார்த்த உடனே அப்படியே ஆன்சர் போட்டுருவீங்க. So I don't want to do that one. I will give that questions to you, and you are requested to solve that questions, right? Fine. Okay guys, hopefully I hope numerical methods is completely understandable by you all, right? Next we have to start immediately. I would like to start vector calculus, right? We will start up with the vector calculus. We will complete vector calculus and differential calculus, and then we will discuss about what I can say probability theorem, right? So today we cannot start vector calculus, right? Because some works are going here, definitely it will disturb you. Already உங்களுக்கு கேட்டுட்டு இருக்கோம், right? So now if I start this one, automatically that will spoil your concentration. So we will start vector calculus tomorrow, okay? If you have any other doubts, you can ask in the group. So let's wind up the class with this. Please revise your notes once again, because mathematics is very easy. You might understand, right? உங்களுக்கு தெரிஞ்சிருக்கும் எவ்வளோ ஈஸியாக இருக்குன்றது இந்நேரம் உங்களுக்கு புரிஞ்சிருக்கும். பட் இஃப் யூ டோன்ட் ப்ராக்டிஸ், நீங்கள் ப்ராக்டிஸ் பண்ணாமல் விட்டுட்டீங்க அப்படின்னா it will let you in trouble, right? So by practice, அது ஒன்ஸ் நீங்கள் ஒரு 50 to 100 கொஷின்ஸ் வந்து ப்ராக்டிஸ் பண்ணிட்டீங்கன்னா மெத்தட்ஸ் மைண்டில் ஸ்டோர் ஆகிடும். தென் யூ நீட் டு மேக்ஸே தூக்கி போட்டலாம். நீங்கள் கொஷினை பார்த்தீங்கன்னா ஆட்டோமேட்டிக்காக சால்வ் பண்ண ஆரம்பிச்சிருவீங்க, ரைட்? பிகாஸ் மேக்ஸில் வந்து ரிவைஸ் பண்ணுறதுக்கோ இல்லை ஃபார்முலாஸ் நத்திங் வில் பி தேர். நீங்கள் அப்படியே 20 out of 20 marks நீங்கள் வாங்கிடலாம். That much easy your maths, right? You can test, take your TRB questions. Already I had given my request, right? You can find it in the Google, right? You can just download it and practice. என்னென்ன கொஷின்ஸ்லாம் வந்திருக்கோ போட்டு பாருங்கள். TNEBக்கு கொஷின்ஸ் கிடையாது. TNEB கொஷின்ஸ் வந்து எப்படி இருக்கும் அப்படின்னா it is almost same as your TRB questions only, but even it is very easy. It's very pretty simple. Just from the basics you will be tested, right? இது நம்ம பார்த்ததில் ஒரு 40% 50% தான் உங்களை டெஸ்ட் பண்ணுவாங்க. If you remember all these things, definitely you can can get first mark. That much easy your question papers, right? But theoretical concentrate பண்ணுங்க, as well as numericalனா big questions கிடையாது. Like 5 steps 6 stepsல questions முடிஞ்சிரும். Only keep your concentration. If you are preparing for TNEB, don't look for big questions. Big questionsனா ரொம்ப பெரிய questions இருக்குது, lengthy-ஆ இருக்குது, அந்த மாதிரி இருக்க questions எல்லாம் you can skip it, right? Very simply how to solve numerically 5 to 6 stepsல வர questions எல்லாம் just concentrate பண்ணி you shall try. Okay, if you have any other doubts you can ask in the group. Let's wind up with this. Thank you all. No, just wind up.